Yeah, so I'm Matt. I just noticed that I'm going to move off that slide because I forgot to update the date from when I gave this at SREcon in America back in March. So I come from a small country down the bottom of the world. Some of you may have heard of it, New Zealand. I was at a Serverless Days conference there yesterday. Flew up here overnight, got a few hours sleep on the plane, so I apologize if I am incoherent. I will try my best to entertain you for the next 40 minutes. Yeah, I've been to a couple of SREcons now. It's my second time speaking, so I just want to say thank you all for listening. As my day job, work as the tech lead for a team in Google called Customer Reliability Engineering. Some of you have been to SREcon before, might have seen Dave's presentation last year or at the Americas conference this year. So I don't have time to go into a lot of detail of it, but very briefly, CRE is trying to take the SRE principles that we use within Google and apply them across the customer-provider boundary. So we want to do SRE with our customers and help our customers adopt SRE as well. There's a link there to video with a lot more details on it. But drawing out of that experience, one of the things that we do with customers in that relationship is a reliability review or a reliability assessment. So we take our experience as Google, all of the mistakes that we've made in the past, all of the sort of institutional knowledge and memory that we have at SRE at Google, and we apply that to our customer's application, and we give them a report. You know, here's some recommendations, here's some mistakes that we've made that hopefully we can help you avoid having to go through and experience. And so that leaves us with essentially a big list of risks. And so what I want to talk about today, and what I want to share with you, is a few thoughts about that. So I want to start with the basics on what is risk, some of my observations about what it looks like and how we should think about it, and then moving on to how we approach it, how we prioritize it, how we tried to do that in CRE, and then how we eventually came to learn and adopt some approaches from the broader field of risk management. So let's dig into that. And what is risk? I'm talking about how to prioritize and communicate risks, and I realize for many of you, English may not be a first language, and so let's make sure that we're all on the same page. If you look at a dictionary, risk is defined as a situation involving exposure to danger. So that seems kind of clear, fairly intuitive, but there's actually some deeper questions here as we dig into this. What danger? And this makes it quite context dependent. So I really enjoyed Ketan's talk, if you were in this room just previously, about SLOs and being very empathetic in our setting SLOs, because SLO really is the key for us as SREs. If you've read the SRE book, this might be a bit of a recap for you, but we need to start with an SLI, a quantifiable metric that measures some aspect of our service that tells us whether our users are having a good experience. Next, we want to set a goal for that service level indicator, and we call that the service level objective. And that lets us quantify whether we are keeping our users happy, whether we are being empathetic to them or not. We don't need to talk about service level agreements today. They are there as well. But then the other concept that you may or may not be familiar with, but I want to introduce you to today, is the error budget, which is the inverse of the SLO. And as SREs, we talk about this because we find it easier to reason about what we have to spend rather than the target that we're trying to reach. So if you have an error budget of 4 nines over a month and you're talking about uptime or availability, you can think about that as roughly 4.32 minutes of downtime that you have to spend in the month. And so with that understanding, with that context of the SRE world that we're working in, we can come back to our definition of risk. And the type of risks that I'm talking about today, and the type of risks that I communicate with customers in my role as a CRE, is a situation that involves consumption of the error budget. So let's dig a little bit more into that. Let's talk about some of my observations on risks and how we can communicate and prioritize and talk about them. I want you to do a quick thought exercise here. Think to yourself, what is the biggest risk faced by the application or the service that you are responsible for in production? What keeps you up at night? Or if you don't support anything in production, if you're in a different role at the moment, think about if you were supporting something in production. If I came to you tomorrow and said, here's a service, Please run this for me. Please keep it reliable. What's going to be, the thing that you think is going to give you the most challenge in achieving that? Everybody got that in mind? Great. So, I won't ask you to share it because there's a lot of people and we don't have a lot of time, but my guess is that if I did ask you to share it with me, many of you would think about things like machine failures, data center failures, maybe natural disasters, events that cause communication outages, power failures. And these are great examples of many of the types of risks we faced. Others of you might have thought of your monitoring practices, your observability into the system, your ability to have an SLI to know how your system is performing. Or maybe some of you thought about your testing and release processes, completeness of test coverage, do you have graduated releases or rollouts? So it's more practice-based things rather than event-based risks. And so I think the observation that I want to make is that risk comes in many forms, and risk is varied. Lots of different shapes and sizes of risk. The second observation I think I'd be able to draw, if I asked all of you to share those risks that you'd thought of with me, is that risk often has very personal aspects to it. It's hard for us to think about risk without our personal experiences, things that have happened to us in the past, also coming into play. So one example of this for me is I happen to be allergic to bee and wasp stings. So if a bee or a wasp, was flying around this room, I'm probably going to be a lot more worried about that, and I'm going to perceive a lot more risk in that situation than many of you who perhaps are not allergic and would see that more as just an irritant. So there's two things to draw from this. One is fact-based. It's reasonable for me to view that as a risk. The consequences to me of receiving that sting are potentially a lot more severe than the consequences for somebody who doesn't have that allergy. So there's a fact-based aspect here. But then there's also a perception-based aspect. There's fear, there's perhaps irrationality in my response. My response might not be in proportion to the actual level of risk that I face. And so it's very hard for us to talk about risk and to think about risk without being influenced by those factors. We're not always rational when it comes to risk. And so think back to that example risk that I asked you to think of, and now think about your colleagues. Think about the people that you work with on a day-to-day basis. Think about the management in your company or people in another job role in your company, the product managers, the salespeople, other people who are stakeholders in the work that you do day to day. How confident are you that that risk that you have in mind, that thing that you want to spend your time reducing, is the same thing that they have in mind? And if it's not, how confident are you in your ability to convince them of that, or to have a reasoned and objective conversation about that? Often I find that when we're talking about risk and we're talking about prioritization based on risk, it's very easy for those conversations to be emotionally based or subjective, and that can lead to a lot of stress for all involved. But before I give you the impression that risk is all doom and gloom and everything about risk is bad, I just want to make the point that risk is also a good thing. Taking risks is what allows us to move forward and achieve things, both as humans and as companies and as professionals. This photo is not of my son, but something that really brings this home to me is I've been teaching my son how to ride a bike recently, and it's probably something that's familiar to many of you. That the whole expression of to ride a bike. At some point, you've got to take off the training wheels, and those first few pedals, with nothing but your own momentum and your own sense of balance, just keeping you going forward. And I actually have 3 sons, and 2 of them are old enough to ride, and just watching the different approach and the different appetite to risk and when they were willing to take that step is another illustration that's very pertinent here as well. So no risk, no reward. Some risks are good. What we need to develop is a way to assess risks, to look at risk and to say, this is a risk that I'm happy to live with, or this is a risk that I need to do something about. So let's talk a little bit about those approaches to risk. The first approach, and I am going a little bit to extremes here just to make the point, but the first approach that I think many people have when it comes to risk, particularly in the software or the operations context, is to ignore it and hope for the best. I want to suggest that, ignorance is not bliss in our scenario. Hope is not a strategy, is a phrase that Ben Traynor, who is sort of the father of SRE within Google, spreads through the organization quite frequently. If you're hoping that a particular thing doesn't happen, at enough scale, it's a guarantee that it will happen. So we can't ignore risk. It's there. If you're standing on the beach, the wave is going to come in and smack you over, regardless of whether you are aware of it being there or not. On the other hand, being paranoid about risk is not a good place to be either, going back to the concept that, risk is not all bad. And this, I see a parallel with the point I'm trying to make here and the stages from Benjamin's talk this morning about gatekeeping. A lot of that gatekeeping stage that he talked about, I think, is about a natural instinct that many of us have to address risk or try and reduce risk by putting barriers in place. I've got my service. It's running well in production. Everything's going fine. I'm going to build a wall around it, and you keep your nasty changes away. Let's just keep everything as it is, and then I'll get to sleep, and our customers will be happy, and everything's great. And I mean, there is truth in that observation, right? Like, my experience, and something that is common throughout Google, is that we know that change is often, the number one or the leading cause of instability in our services, so that there is truth behind that. But our job as SREs is not to inhibit change. Our job is to engineer the system such that we can achieve the highest possible velocity for getting changes out to production while protecting that SLO, while keeping the service reliable. And so if we're stopping those changes getting out, we're failing at our core job as SREs. The other thing I want you to consider, if that alone is not enough to convince you, think about what's going to happen if you've succeeded in holding that line and you've succeeded in stopping those changes coming. And maybe, one example that makes this very real is you have a freeze over a holiday or over a particularly sensitive time for the business. It's not necessarily always a bad thing to do, but in my experience, the next release after you've had that freeze has twice as many features, has twice as many changes in it as normal. And so you can reasonably expect that there's going to be twice as much instability. Or even if there's the normal amount of instability, there's twice as many potential causes, so the debugging is twice as hard. So that's just another set of things to keep in mind that, change, trying to avoid change is not really a useful strategy for avoiding risk either. Entropy always wins. So if we can't ignore risk, if we can't prevent risk, what we have to do is manage it. We have to engage with it. And for each of the risks in our application, we can choose whether we're going to try and eliminate it, whether we're going to try and reduce it, or, in some cases, whether we can avoid it. And this is a different sense of avoiding to just ignoring it, but this is actually taking steps to, take ourselves out of the path of that risk. The problem with these three things is that doing any one of them for an individual risk takes time, and so in aggregate we're talking about a lot of work here. And we're all time poor, we all have a lot of demands on our time and a lot of different things that we have to achieve. So what we actually need to talk about is prioritizing. How can we take a set of risks and prioritize, which ones are the biggest threat to my error budget? Which ones should I be addressing first? Or which ones do I need to mitigate, put a little bit of effort into to take away the bulk of the risk before I can move on to the next thing on the list. So hopefully none of that is particularly controversial to anybody. That's my introduction to risk as a set of concepts. Hopefully it's more of a review. And so now I want to talk about how we have found the method that we have found most useful to prioritizing risk today. And I don't really want this to be controversial either, but I do want to suggest that as an industry today, most of the way that we tend towards prioritizing risk is via intuition. Intuition is a wonderful thing. You know, we have instincts which protect us from a lot of physical risks and do a wonderful job of keeping us alive most of the time. But there's a lot of research out there, and there's a lot of knowledge that, you know, social scientists have been aware of for a long time, and I think we as SREs and operations and software engineering professionals are starting to become more aware of, that tells us that actually when we're talking about the sort of complex software risks that we face, our brains are actually pretty terrible at intuitively prioritizing and assessing those things. So if we've got this list of risks and then we're trying to have a discussion and we're trying to prioritize them just as a list of things using our intuitive judgment, I think we're going to have a pretty bad time. So some examples of this. We tend to perceive high risk from things which are novel, things that we haven't seen before, the movie plot threats, if you will, or maybe things that have happened more recently. You know, we read an article last week about another company in a similar space to our had a data center failure, and it was really bad. They were down for 13 hours. So naturally, the next week when I'm at work, if I see data center failure, you know, on my list of risks, that's going to figure more prominently in my head than perhaps something which seems more mundane to me, the deployment strategy that I'm using. Mood and environmental factors at any particular point in time can also affect our judgment. There's a famous study that was done on an Israeli parole board that some of you may have heard of. So this is a parole board, judges hearing applications for parole from prisoners. These are people who are professionals in weighing evidence and hopefully making a reasoned and balanced judgment about it. But what the study found was that there was a predictive effect on the time of day when your parole application was heard and the probability of it being successfully granted. If your parole application was heard first thing in the morning or directly after lunch, there was a much higher probability of your parole application being granted than if your parole application was heard just before lunch or right at the end of the day. And so if professional judges, you know, people who are experts in making that sort of reasoned decision can be influenced, can be affected by bias, you know, because of mood and environmental factors, I don't think there's much hope for me, and I think many of you would agree, like, not much hope for any of us if we are just relying on intuition. And so these are becoming more well-known, and that's the first step, right? Like acceptance, admitting that we have something to address here. But even just knowing these problems exist doesn't help me next time I sit down and try and prioritize a set of risks. Even if I know these problems exist, I'm not necessarily going to be able to combat them unless I can find a system, or unless I can put a process in place, something that's going to force me to go through a series of steps, which is going to take the process out of my brain, and it's going to make my thought process visible to you and allow us to have a much more objective discussion about the risks and the characteristics of them that we are trying to address. So we want to find a process that can break it down like that, and so that's where we started our journey in CRE. We had a list of risks. The customer that we're working with wants to know which ones should I focus on first, and tell me about them. Like, tell me why you think this is a risk for my application. So in talking to these customers and in talking, you know, within our team and in drawing on some of the experience from a wider set of teams in Google, we identified two characteristics that most people seem to find fairly intuitive to help with characterizing a risk. And so those two things are the likelihood and the impact. So likelihood, you know, we can say is the probability or the frequency of occurrence. What's the chance of me being stung by a bee today? The impact is what happens when that occurs, you know, in the context of your software systems. How long is it going to take you to resolve that impact and get back to a state where your users are satisfied with the system? And so we started trying to prioritize risks in this way, and we assigned 3 rough buckets to each category. And so it gave us a 3x3 matrix, which, you know, is very naturally organized in this fashion. And so for likelihood, you know, we said things could be frequent, they could be common, or they could be rare. And for impact, it could be catastrophic, it could be damaging, or it could be minimal. And so we put a set of risks like this, and we presented it to the customer. And feedback was good in general. But looking a little bit deeper into it, the first thing we noticed was that we weren't really using all of the categories when we started doing this for real systems. It was far more common for us to put something in the common damaging category. We were ending up with lots more in that bucket than we were in frequent catastrophic. And so that's not really helping us with the stack ranking because everything is in one bucket. And so now I've just got to prioritize in that bucket. Great, haven't really helped myself a lot. But so maybe we can define a ranking over the cells, and that'll help a little bit. But then you get to the situation where, let's say you've got one common catastrophic risk and 10 frequent damaging risks. Intuitively, it might seem like something that's common and catastrophic is more important for you to address than something that is frequent and damaging. But then if you've got 10 of them and one of the other, is that still true? So the conclusion was that this approach is very useful for communicating a set of risks. It's much easier to understand than if I give you, a 2-page bulleted list. A matrix is great for the communication purpose, but it doesn't really help us with the prioritization. So we need a better approach. And by this point, I'd been doing some reading, and we started to become aware, maybe we should have become aware earlier, but at least by this point we started to become aware that we weren't really the first people in the world to try and prioritize risks in this way. There's probably some existing thinking out there already. And it turns out that there is, and it's called expected cost, and it comes from this field of study called risk management, which is actually very widely used. If anybody here is from a financial firm, you probably hear about this. There's professionals in your organization that use this sort of thing every day. It's also very big in the manufacturing and oil and gas fields. And so I think there's a lot that we as software engineers and operations professionals can take from these existing industries. And so what it does is it takes those two characteristics that we've already identified, takes the likelihood of a risk, and it takes the impact of a risk, and it multiplies them together, and it gives you an expected cost. So if we can find a way to quantify the likelihood and quantify the impact of our risks rather than just grouping them into those 3 buckets, then we could apply this to the list of risks that we've identified, and we could have an objective way to prioritize our risks as well. So how do we do that? What are our steps? Well, the first thing is that when other industries do this, they often deal with financial costs. If my oil well blows up, what's the cost of that? I think dollar cost, financial cost, is not always the most useful metric for us as SREs to directly deal with. It's always useful to be able to make that mapping back, but on a day-to-day basis, it's not always clear. If you're directly selling things, you might be lucky and you can quantify a risk of outage directly into a financial cost. But you might be working for a non-profit or somebody giving something away where the financial cost is not as apparent. But go back to what we talked about at the start, and we have something called an error budget, and budget is related to cost. So if we can talk about the expected cost of a risk to our error budget rather than to a financial cost, then we might be able to make this work. So here's expected cost from an SRE perspective. Likelihood, we can quantify as the MTBF, might be the common term that you've heard, the mean time between failure. How often does this risk occur? Now, ideally we would do this from some historical data about your application, or at least about your organization, a history of past incidents that you keep with sufficient granularity that you can pull it out for all of the risks that we've identified. Unfortunately, not many organizations that I've come across have that level of data granularity. Even within Google, we don't necessarily have well-organized data at sufficient granularity to do this sort of risk analysis. So what we usually end up talking about when we do this as a CRE team with a customer is an estimated value of the probability. And so I've called that ETBF, estimated time between failure. Or you could also think of it as estimated time to failure, like how many days before you think this risk is going to eventuate for your system. For the impact, we can call it the time to resolution. And again, MTTR, mean time to resolution, or we could call it ETTR, the estimated time to resolution. And what we've found really useful and a useful way to help us to reduce bias here and to start to combat that sort of psychological matter of dealing with risk is if we break this into two categories. We can talk about ETTD, how long is it going to take us to realize that this thing has happened, and then once we realize it's happening, how long is it going to take us to restore service to normal. And so by quantifying those characteristics of risk in that way, we can end up with a cost. Excuse me. So those of you who have heard of this technique before or are familiar with the more general field of risk management might see where I'm heading here. Our next step was to record this, to create a list of risks that's called a risk register in the general field. And so the link there, the QR code, will take you to a spreadsheet that you can use today, and I would love for all of you to do this for your application, for your service today. So what you do is you sit down and you do a thought exercise. You know, some people call this what could possibly go wrong. Other people practice, Failure Fridays, doing wargaming exercises. These are all great sources of input to your risk catalog. And so you populate that spreadsheet. And again, just do a quick thought exercise for me if you'll humor me here. Look at that list and just quickly stack rank it intuitively in your head. Like, which of those risks, if it was your application, would you target first? And we'll come back and see how that intuitive assessment lines up shortly. So keep that in mind. But now we're going to go across each row, and for each of those risks, we're going to estimate the values. So for the operator accidentally deleting the database, we can say that, well, if I accidentally drop my database, I'm going to work that out pretty quickly. So the time to detection is 5 minutes. But to restore, that's actually going to take me quite a lot longer, number of hours. I'm going to have to restore from backup. Disks only work so slowly. Sorry, disks only work so fast, or Freudian slip there. But actually getting that data back off backup and into the database is going to take a number of hours. It's going to affect all of my users, but hopefully it happens really rarely, once every few years. Whereas for another risk, a bug in a new release breaks an uncommon request type, well, it might take a really long time to detect because it's only a really small fraction of requests. Quick to roll back. Only affects a fraction of users, but maybe it happens once a quarter. So you can see how you can go through each of your risks like this and estimate these values. Your estimates don't have to be perfect. They are only estimates after all. And as long as you're roughly consistent across each column, it doesn't even matter if you are completely biased in one direction or another, as long as that bias is consistent across all the risks. But also by breaking out the individual components in this way, it makes the discussion a lot more objective. Rather than you and I debating whether one of those uncommon bugs is more likely than one of us accidentally deleting the database, we can talk about the individual characteristics. Like, how long is it going to take us to restore from that condition? How long is it going to take us to detect that condition having occurred? So we've put ourselves in a position where we can have a much more objective discussion about it. But, disclaimer here, short disclaimer, at the end of the day, we are still talking about estimates. What we're trying to get here is a way to prioritize our work. It's not going to give you a numerical guarantee on what your SLO is going to be or what level of reliability that you're going to achieve. And at the end of the day, it's a prioritization that you can take and put into the rest of your business planning processes. So with all of that, we can get the spreadsheet to do the calculation for us and get the cost, which we can express in bad minutes per year against our error budget. And if you're following along on the spreadsheet, this all happens on the first sheet in there. But then if you flick over to the second sheet, what we then do is we can take it and we can put it into the stack rank. And that's the prioritization that I've been talking about. And so you can do a quick assessment now, like your intuition versus the estimates I had there, Did it match? Was it the same example? If not, maybe you want to come and argue with me later about, maybe my estimates were wrong. But we can have that as a very objective discussion. So this is a good list, but there's a couple more things that we can do that make this useful. One of the other points that Ketan made in the talk before this was you don't necessarily need the level of reliability that you think you need for your users. Many of you may have been in the situation where you get asked to deliver a feature, and when you ask the product manager or the salesperson bringing that feature to you what level of reliability is needed, the default answer is 100%. I need this to work all the time. And so what this sort of analysis gives you is a way to, again, objectively and quantifiably demonstrate and put that conversation on a footing where it is databased. So what we have here is another column in the spreadsheet, or represented on this slide, where we've put in a particular error budget target. So in this case, I think I've put in 4 nines here. And so that's a 52-minute, 53-minute error budget over the course of a year. And what we do then is we color the cell based on how the bad minutes per year for each risk relates to that error budget. And in this case, we say that anything that consumes more than a quarter of the error budget in a single risk is just unacceptable. We can't live with that level of risk in our system because these are just estimates. And if I'm going to lose a quarter of my error budget with a single particular event failing, that's something that I do actually need to put some effort into now. And so those cells get turned red. And so you can see, if we are choosing to take on a 4 nines SLO for this service, we've got a lot of work to do to address all of these risks. So the natural question that you can then move on to in the discussion is, well, maybe we want to drop our level of reliability. Maybe we can actually retain trust of our users with only, what did I put here? 3 nines of reliability. And so you'll see the color changes, because now with a 525-minute error budget, those 3 rows at the bottom there all sum comfortably within those 525 minutes. So we can turn those green, and we can say we're going to accept those risks. Risks that we accept, we don't need to do anything about. If they occur, if they happen, we'll have an outage. It'll be unfortunate, it'll be uncomfortable for everybody involved. But at the end of the day, if our estimates were accurate, we're not going to go out of our SLO. Now, in reality, you're probably not going to be quite that comfortable about it because they are just estimates. And so you might actually want to do something to mitigate these risks just so you've got some safety margin there. But again, as a tool for helping you visualize and helping you have a conversation about a target level, it can be very useful. The next thing you can do here is, let's say I took out the bottom line there, which was just a single risk, and let's say there's a whole lot of things that actually sum up to 407 minutes. And so there's only 2 things that are in our acceptable space now. And then so we've got a cell that's marked in orange here. And this is something that doesn't fit in the error budget. We can't accept it. But at the same time, it's not greater than 25% of the error budget. So we're not willing to say it's unacceptable. We could potentially choose to accept this thing. If we do, what the spreadsheet will do if you're playing along with it, and so you can accept it by putting a letter in the cell, a yes or an X. So what will happen if you do that, you accept that risk, you take it into your error budget, and the green will move further down, and you'll get some other things show up in orange. And so this is a way that you can interactively play around with what work you're going to do to reduce the risks facing your system. So again, I'd love for you to take the spreadsheet, play around with it, give me some feedback, tell me how it goes for you. The feedback that we've had to date is it's a great tool for having these conversations. So wrapping up, before I take some questions, if there's any out there. The first takeaway is that the fundamentals for SRE is that every service needs an SLO. You need to define an SLI that is an indicator, a quantifiable metric of what your users care about for your service, and you need to set an objective for what you're going to keep that metric being. And that is the foundation for everything that we do as SREs. The next unfortunate fact is that, risks abound in the world. It's a fact of life that everything is against us. Everything is trying to make it hard for us to meet that SLO. And so our job is to be risk managers. We want to identify all of those things that are trying to fight against that SLO, and we want to be able to proactively reduce them, take them to a level where we've managed them, and we know what we are, and we know what that risk is. And the more we do that proactively, the more we take those sources of chaos and uncertainty out of our systems, the more we can then choose to spend that remaining error budget on delivering features, getting releases out the door, and doing things that actually bring value to our business. As humans, we're not great at prioritizing risk, so we need a system to help us do that prioritization. And I want to present to you today that a great system for doing that is to take on the costs, the concept of expected cost from the field of risk management, impact, likelihood, estimated time between failure, estimated time to recovery. Add in some extra factors like the estimated time to detection, percentage of users affected to help bring those biases out and make it more reliable. And then please try it today. We've got a spreadsheet. You can do this on a bit of paper, but the spreadsheet makes it nice and easy. Please take it, use it, modify it, do whatever you like with it. Tell me how you get on. Thank you very much.